Okay, welcome to this session where we're going to look at Module 3, which relates to financial analysis and maintenance management. Now, the key thing to remember, of course, is that we're not trying to turn you into an accountant or turn you into a financial expert. But the reality is that there's some good terminology and some concepts that are very, very important that you should realize and obviously be able to put into practice. And when you're at a meeting or when you're hearing these kind of expressions being used, you should feel a bit more comfortable about it. Okay, so let's begin. Have a look at a few things. So, Module 3, Financial Analysis and Maintenance Management. Private and public organisations, they rely on assets to provide products and services. Okay, no big surprise. To provide those desired service levels, function safely for the personnel and the public and the environment, and economically or profitably, then obviously we have to financially ensure that they're being well maintained and reliable. So they're dependent upon the effective performance of those assets. Beaver 2000 talks about maintenance accounting up to 40% of an organisation's cost. That's quite a huge investment, but as you know yourself too, in dealing with maintenance issues, you're always arguing about production, marketing, etc., trying to get a bit of muscle into your needs and requirements for your maintenance. So 40% is certainly a huge hole if you can't get that much of the budget. And as you know, you won't be getting 40% of the budget, so keep that in mind. Maintenance, so well, a significant user of human and financial resources, as we see, 40% of it from that particular study, contributes directly to the cost of running an organisation. Okay, if something breaks and you can't go from A to B or you can't produce your product, well, certainly will contribute to the cost of running. Targeted, sometimes unreasonably, as a unit, because we'll cut costs on the maintenance. We're going to have to do that because we need to, basically look at, some other area of our particular organisation. So, as a result of those types of things and being targeted, and as we say, sometimes unreasonably, then we can see that maintenance costs are a high proportion of the organisational costs. We said 40% by that particular study. Now, other studies might have different values, but we're working with that one as a baseline, as a comparison anyway. And maintenance costs are not regarded directly related to the asset function or production output. That is opposed to, say, you need raw materials, you need that coal to come through to burn in your fire, so that you can produce electricity in your furnaces. You need gas coming as a raw product to, heat up your ovens. So consumables or fuel, which are direct requirements of producing the service or the product. Also, if we look at maintenance personnel, they're often unable to articulate the impact of decisions to cut maintenance expenditure on the output of the assets or the profitability of the organisation. Or you can turn around and say, well, if we don't maintain that thing, it's going to break at some stage and fall over, so therefore then it's going to stop production. Yeah, well, that's a bit too nebulous, or, too far away. As you know, there's those time lags that we've spoken about beforehand. So it's hard to keep arguing to management or to other areas or other units that maintenance is a necessity that has to be done at that particular time, or obviously be continually being considered as an important process, an important area that needs funding to keep it going and keeping the whole machine working. Financial analysis techniques and models in maintenance are primarily applied for the control the cost of the maintenance to agreed levels. So obviously that's what you're doing in your budget discussions. Make economic decisions where choices present themselves for the acquisition or maintenance of assets. So again, you're going to turn around and say, okay, well, this year we're going to have these acquisitions, so therefore then you're going to have to argue back through your your processes, through your funding for your unit, that's what's required. Financial performance and maintenance management, well, the tangible outcome that reflects the true performance of the business and one against which the contribution of maintenance can be measured. So in other words, if you've got an efficient, well-working maintenance managed strategy, processes, you're going to have shutdown, but it's all been planned out, obviously, and it's not, hopefully it's planned, compared to not having it planned. Unscheduled shutdowns are, of course, going to cost money, more so than scheduled shutdowns, because suddenly it's shut down without any warning. If there's been a major problem, then of course you've got to go and problem solve, find the root cause analysis perhaps, and figure out what the problem is. Whereas if you've got a scheduled shutdown, you've already figured out what needs to be done. So as you can see, the financial performance from your maintenance management certainly does reflect on the organisation and its capabilities. All right, so some important financial terminology. Capital cost, what does that mean? Well, it's the purchase of tangible assets, plant and machinery, and intangible assets, trademarks, software development, that type of thing. It's not limited to the initial construction of the plant or the factory, but includes the purchase of new machinery to increase production. Does not include labour costs, only included if in the construction phase, and one-time expenses with payments spread over many years in the financial reports and the tax return. So you spread it over. You know, it's not have to go back in this tax return. Your capital cost is fixed. Costs the same whether operation is closed or running at 100% capacity, therefore independent of the level of the output that you're putting through, you know, for stopping or, as you see there, running at 100%. The operating cost. Well, the operating cost is related to the operation of the business, the piece of equipment, or the facility that you're operating in. It is the cost of resources used by an organisation just to maintain its existence. So you can talk about fixed operating costs. They're the costs which are the same whether the operation is closed or running at 100% capacity, therefore independent of level of output. Includes the rent on buildings, the rent of the site for argument's sake, and they have to be paid regardless of what the state of the business is in. So, you know, if everything's shut down, you've still got to pay your rent, you've still got to, you know, pay for, you know, your access and to your site and that type of thing. Your variable operating costs may increase depending on whether more production is done and how it is done. So, okay, as an example, if you're producing 100 items of product that might require 10 days of normal time or take 7 days if overtime is used, it may be more or less expensive to use that overtime production depending on whether faster production means the product can be more profitable. In other words, you know, are you paying so much for the overtime that it basically, you know, chews up the amount of profit that you're going to make by getting them out there quicker. So the variable operating costs include the electricity use, phone services, payroll services, office products, computer supplies, credit card processing, cleaners, waste disposal, all those types of things. So as you might imagine, that's a lot to understand and a lot to juggle in those terms. So most common financial analysis techniques, well, we talk about life cycle costing, and that basically is where we consider the total cost of ownership of an asset in any financial decision-making process. So we're going to buy a brand new item, we're going to figure out from the time we purchase it, the delivery of it, oh, hang on a minute, why did we make this decision? So you'll see that it really does encapsulate the whole life cycle from conception, if you like, of why you need it, all the way through to how do you dispose of it or sell it on, for argument's sake. So the life cycle costing considers all costs for the asset: designing, acquiring, constructing, operating, and disposing. This is decision-making. The costing analysis is conducted for best options. One, compare whether to repair it or replace it, or to select between, you know, different asset acquisition options. So you might think, okay, well, we'll go with what we've already got. We'll have to patch that up, but we'll be able to go and spend, you know, money on something else, in other words. Asset replacement decisions, they're concerned with when should I replace a particular asset. This includes a number of options. You either replace an existing asset with another, in other words, an equivalent from a competitor. So if it's a bulldozer, for argument's sake, and it's a Caterpillar, well, then you might go and get a Komatsu. So you've got an existing asset, you just go and replace it with an equivalent D9, for argument's sake. Asset replacement decisions include the other option, which is determining the economic life of an asset. This is the expected period of time during which an asset is useful to the owner and could be different from than its actual physical life. So in other words, its working life, there it is, but then you could use it for spare parts, for argument's sake, or you could sell it on as spare parts, or basically find some way for its economic life compared to its physical life and actual pushing, let's say, as a bulldozer, pushing dirt around, or what the case may be. Still dealing with most common financial analysis techniques, discounted cash flow analysis. As I said, we're not trying to turn you into an accountant, but these are important things that, you know, if you've got some idea of them, you might be able to, you know, better appreciate what, you know, some of the discussions that you're going to have with your financial people. So discounted cash flow analysis, it's summarized cash flow out and the cash flow in, disbursements, for a particular asset over time. So you project future financial transactions in present day dollar values. Benefits or options are compared and contrasted in current dollar value. So in other words, you have, you know, this particular item, and you say, okay, it's worth this so much at the moment in present day values, and okay, so you say, okay, then, well, in future values, what will it be worth? Is it a benefit or an option that we're able to, you know, keep it because it's going to be quite comparable value, Is it, of value, etc., or is the option that, obviously it's far less value than at current values? Now, the way that money works, of course, is that, if you compare money from a previous time or money for a future time, then because of the way the stock market works, the way that values of money works, etc., then it will have $10 will have a different value in those contexts. So this process, when you do the calculation, it calculates in current dollar value. So you're comparing like with like. So if you're looking at future values, you take that value and you're able to convert it back to figure out, oh, okay, so therefore then it's worth this or worth less, to be honest. Okay, so discounted cash flow analysis, you compare the capital cost of an option to the expected financial return to determine a payback period for an investment. Payback period, well, that's expressed in terms of years. Typically, if it's greater than 3 years, it's considered that it's not a viable strategy. So keep that in mind. Return of investment, it's expressed in currency terms, and it's the minimum rate required for a proposal to be accepted. The internal rate of return, this is expressed as a percentage. A minimum internal rate of return, called a hurdle rate, is required for a proposal to be accepted. So in other words, there's a certain value you'll go up to. That's the hurdle, if you like. If you can't get over that or you can't expend that, then obviously you need to make decisions related to that. Cost-benefit analysis, it's a subset of the discounted cash flow analysis. It's used to justify actions based on analysis of financial costs and returns of an expected action. It ranges from simple to complex analyzing depending on size, nature, and action to be analyzed. So cost benefit. So again, it might be from leasing some machines compared to buying them. So the cost benefit analysis might be that, it is actually better in the short term to go and lease those pumps compared to buying those pumps. Because, like, for argument's sake, a few times there's been flooding in mines out west here of Rockhampton, and the point is that you need to get that water out of there. So instead of going buying, these pumps, because a large flood event like that is only ever 8 years or 10 years or something. So the point is, you might say, as a cost benefit analysis, it might be better to go and rent those pumps to pump out that part compared to buying them and then obviously use them. Yeah, you're going to solve your problem, reduce the problem at least, maybe solve it perhaps. But the reality is then you've got those pumps you paid for. Remember, the mine's not operating because it's flooded. So therefore then the cost benefit analysis might be better to rent those things, use them for a certain period, get rid of them, and then move on. So they're not sitting around basically rusting, ready for the next flood in 8 years' time. So are they going to really be, usable in 8 years' time? The life cycle cost analysis that we were referring to beforehand is that when you have an asset-intensive organization, envision, design, and acquire assets to achieve a particular purpose, service, or product. Okay, the asset acquired using specific criteria for achieving a certain capacity, the output, the rate, the quality of it, whatever it is, for a certain cost, the profitability, the economy of the operation. So when you look at this asset life cycle, basically we're going to tease this out basically and see what these things mean. So here's the stages. And that's what I was saying about before. With these life cycles, really it is from conception through to death, if you like. In that context. So first of all, what's your needs? Well, you identify the need for this particular new asset, this new pump, this new bulldozer, this new grader, whatever it might be. And that commences the life of a new asset. Now, you need to identify on the basis of requirement or opportunity for a new item for a new purpose. So Komatsu might be saying, oh, okay, then we've got a run-out sale on D10s because we've got a new model coming in, so there's an opportunity. So even though you think, oh, we weren't really thinking about buying a new D10, the reality might be that this is an opportunity that's come up right in the place. Justification, well, you ensure the cost of obtaining the asset can be justified in business terms, no big surprise. Additional income generated, obviously they'll cover that. Reduce cost or improve reliability or improve safety would be some of the discussions that you'd have and some of the reasoning that you would use to justify why you want that particular asset. And it may include feasibility studies for larger assets, new processes or plans. For obvious reasons, they're going to be perhaps millions of dollars, hundreds of thousands of dollars to do those kind of things. Specification, well, as you might imagine, it's just the definition of the attributes of the asset for purposes of purchasing or construction. So again, if it's a D10 or something, well, you want that because you need to be pushing lots of stuff around and do it quickly. The specification, besides technical specification, the capacity, the size, the power, whatever it might be, it can also include aspects of asset reliability and maintainability. So, you know, particular machinery might not be totally reliable, and through, you know, industry you might know, no, don't buy that product because it's not very good. So therefore then it's not just that, you know, okay, it might be a D10, but because it's from another company that's not reliable, maybe the servicing is not reliable, maybe delivery is not reliable, maybe the machine's not reliable. So therefore then it's not just that it's a D10, the reality is that you don't really want that particular D10. So it may include preliminary or detailed design of large assets, and then you go back around again and think, oh, hang on a minute, that specification is going to change now, so therefore you have to go and do a redesign, or you know, do perhaps more detail, or rethink the whole design perhaps. Procurement requires, you know, refers to that actual purchase of the asset. So you got to order it, get it delivered, so you're procuring it. Awarding a purchase to the supplier, successful supplier awarding a contract to a successful tender. So obviously you want a new D10 bulldozer, so you'd say all your specifications that you want, put that out to tender, and then Komatsu, Caterpillar, everybody else comes along and says, oh, here, this is what we can do for you with regards to the actual machine, the maintenance, spare parts and stuff like that. Then the next stage is the installation of the construction. In other words, once you've got this thing or you're about to build it, then you have to go about doing it. So once the machine arrives, you either have to bolt it in somewhere, or you've got to go through the processes of installing it and getting it in, you know, out on site. The extent of this phase is dependent upon the size and type of the asset, as you might imagine, compared to if you're bolting down a new piece of machinery, compared to perhaps constructing, you know, a new wash plant. As you can see, it depends on the size and type of asset. The commissioning, well, actually now once it's there installed, you've got to test run it to see that it's going to operate appropriately. It's not going to blow up when you push the button and all that kind of stuff. So you basically install or construct equipment that's test run and checked against its original specifications. Utilization, defined as the useful life phase of the asset. The asset is used for its intended purpose, including its operation and maintenance. So, you know, it might be years, might be, yeah, quite a long time. Review and disposal, well, assets performance, cost and effectiveness is reviewed, and now it's either too old or too costly to maintain, or there's a new butte model of some sort, so therefore then you've got to figure out the cost and the effectiveness of it, so you're reviewing it. And then if you are going to dispose of the asset, are you scrapping it, or are you selling it off as parts, are you selling it off as a whole? And the life cycle commences again for a new asset following the disposal of the old one. So you go all the way back up to the conception stage, which we said beforehand. As you go back up here, you conception or the identification, and then off you go again. You justify why you want this, figure out the actual specifications, blah, blah, blah. So the cycle goes on. So if we look at life cycle cost analysis and the total cost of the ownership, then what we've got to take in mind here is, or keep in mind here, is that, you know, buying the cheapest asset is not always the best thing. Okay, so sometimes, you know, cheap is nasty. So warning, buying cheapest assets, not always cheapest option in the long term. In other words, it may require more maintenance. It may be old technology, because you could be buying a particular model that's now being phased out and there's a new butte model coming along. In buying the cheapest asset, there are hidden costs arising from poor reliability, performance, spare parts. Again, if it's being phased out, maybe those spare parts in another couple of years aren't going to be easy to get, and the operating costs, of course. You can make total cost of ownership higher because obviously you now owned it, and now, of course, because it has these ongoing issues, high maintenance, hard to get spare parts, got to patch it, then obviously that total cost of the ownership is going to increase. Blanchard 990 highlights the folly of buying the cheapest asset. Capital cost of an asset is only the tip of the iceberg of the cost considerations. In other words, yep, great price, but terrible product. Need to consider the total cost of ownership of an asset. Includes all costs associated with the phases of the equipment's life cycle, so the purchasing, the running, the maintaining, disposing of the asset. And in both those cases, those hidden costs, the poor reliability, performance, spare parts and stuff, have to be taken into consideration. So you need to consider these aspects of total life cycle costs. Cost of needs, you know, for identification of it, the cost of the justification of going about and proving why you need it, the cost of the specification, going and getting all those technical reports and doing comparisons and contrasts and saying, oh no, we don't want that one, we want this one, and of course going through the whole process of the cost of the procurement. So the life cycle cost analysis, again, still concentrating on the total cost of the ownership. That life cycle cost components can also be classified as the cost of use, materials, energy, Labour costs, the lost output, opportunity costs, of course. The cost of ownership is, again, cycled all the way through those stages of the life cycle: the acquisition, the installation, commissioning, maintenance, modification, repair, monitoring, and replacement, all fall within that life cycle stages. The cost of administration, so there's the data acquisition, the data recording on that particular device, the data analysis, and of course all the documentation. So it's holistically looking at your costings. Note the trade-off between costs of the phases of asset life cycle. Example, you have a higher cost of specification, more effort put into the specification of the asset, so you've got to go around, check out 4 different types of D10 compared to only doing it for 2, for argument's sake. So that takes more time, takes more resources, and that could result in a lower cost of utilization. So you spent that money going about doing that, so therefore then it hasn't been allocated with regards to that next phase of actually, once you've got it, procured it, and using it. If the life cycle cost is lower than worthwhile doing, so in other words, you're trying to achieve outputs while minimizing that life cycle costs. So we're always trying to balance these things. So if these things are going to cost you more money, really the cost of administration, if you're spending all that time or all money, and time is costly as well, don't forget that, it's not just cash. So therefore then if you're spending time and money and effort on those things, then in actual fact that machine is costing you all these hidden costs that we're talking about. So the main aim is to achieve outputs while minimizing all those other life cycle costs and incorporating those hidden costs that we talked about with regards to liability and stuff. All right, so life cycle cost analysis, the asset maintenance management focus. Let's look at that. So asset management is concerned with all aspects of the asset's life cycle. It includes the engineering, financial, operations, and maintenance management. So it's designed, obviously, to minimize that total cost of asset ownership. Maintenance management primarily concerned with the asset's utilization phase of life cycle. In other words, that other part of the life cycle, the identification of it, the justification, all very, very important. But the reality is that in terms of the maintenance, process, it's really in when you use it. You're going to be spending most of your time as a maintenance engineer trying to, make this thing be usable and to be usable for as long as possible. So that's why, maintenance management is going to be primarily in that utilization phase of the life cycle. Life cycle costs, significant proportion determined at the design or selection phase. In other words, if you're designing, as I say, the wash plant, for argument's sake, if it's a bad design to begin with, well, it's cost you this much, and if it's a bad design, it means it's not going to operate very well, so therefore it's going to give you, either going to patch it or it's just going to be bad product coming out the other side. It's not going to be, suitably washed as a wash plant. Or an oven or whatever it might be on a production line. If it's a poor design, well, then obviously it's not going to match in properly. It's going to cause problems. Or again, the selection phase. In other words, that D10 I was talking about beforehand. You chose, you didn't choose the Komatsu, you didn't choose the Caterpillar, you chose something else. So, so a significant proportion straight away before this machine even arrives or starts going, could be, the life cycle cost could be significant portion of that. So consequences, impacts most on the total cost of ownership, obviously. Blanchard and Fabriati in 1990 indicates 95% of the life cycle cost is predetermined at the end of the design phase, so way back at the start, in actual fact. So the dilemma is you cannot influence the cost of ownership by maintaining and operating practices. Can you? Cannot. You cannot influence the cost of ownership by maintenance and operating practices. That's what it's really telling you. So no matter how well you do your maintenance, how efficient, then if you've got a bad design, well, then you're going to have to keep maintaining this thing, or you're going to keep patching it. Or if it's a bad selection, then no matter what you do in terms of your maintenance and your operating practices, it's going to, basically keep contributing to that cost of ownership. So it's very difficult to influence it past that phase. So the reality is that the role of operations and maintenance management during the utilization phase, in other words, while you've got this thing, is to perform maintenance to incur reasonable costs, seek to minimize losses in output due to the poor maintenance practices, and look for opportunities to reduce utilization costs by improving, obviously, aspects of the equipment selection, the design, operation, and maintenance processes. All that selection, design stuff, as we said, further up the chain is where basically 95% of the life cycle costs. So you need to be able to get in there as a maintenance person and say, hey, listen, I've got to maintain this thing. I think I know 1 or 2 things about design, or I think I know 1 or 2 things about the selection of that particular product, bulldozer, oven, whatever it might be. So I think I should have some say in this part up here, this design phase, justification, that type of phase. All right, life cycle cost analysis, and we're still looking at the asset or component replacement when we talk about asset or maintenance management. So maintenance decisions for replacement of components or replacement of the entire asset, it's based upon the component or the asset becoming obsolete or uneconomical. Yeah, makes sense. The maintenance cost being too high. You just got to keep patching this thing up. Obviously, it's not good. Component or the asset has failed or is failing and requires replacement. The availability cannot be maintained. Component or asset no longer supported by the manufacturer, so therefore spares are unobtainable as an example. The organisation presents new investment opportunities. Okay, so therefore then there's a whole range of other options to give replacement of that component or the entire asset. So in making maintenance decision, the necessity is that maintenance practitioners make choices based on sound financial analysis. And as I said, you don't have to be an accountant, but some of this lingo and some of these terminology and some of these concepts are very important to you so that you can soundly argue financially as well as technically in regards to why you want that asset or why you don't want that asset to be purchased. Decision-making models. Well, Jardine in 1973, which sounds like a long ago, but keep in mind that these theories, just because it's 1973, doesn't mean it doesn't operate anymore or it's not useful. And again, this mathematical model, it was used to develop a solution or make management decisions. So it understands the objectives of the decision. You develop a mathematical model describing and simulating the behavior of the investigated system in terms of obviously a range of variables that you have for that particular system to represent how the system operates. Evaluate the model variables to obviously decide the best option to adopt. So it's a what we call a max-min problem. You maximize this, but maximize these benefits, if you like, and minimize those problems. So the purpose of financial decision-making model, it provides a basis for evaluating options using cash flow inputs. So cash flow, if you remember, is the money in, the income, the receipts or your benefits, and the money is flowing out. Obviously, your expenses, your payment of staff, your payment of this item, you don't always go and pay cash for it, you might be in some sort of payment, and the losses, of course, if you haven't made a profit this year. So decision-making models can be qualitative or quantitative. A quantitative decision-making process is based on measurable numeric inputs used in models to predict outcomes and determine the best choice of action. So you crunch the numbers, basically you crunch the numbers. Crunch the numbers and out pops a number or a range of values and you say, okay, yeah, we can operate within that. That gives us a safety margin in terms of the finances. The quality decision-making process, well, that's based on characteristics that cannot be effectively represented in numerical terms. Oh, those Komatsus are always good. So I'm a Komatsu man, so we always buy the Komatsus in this company. So yeah, really, where's your proof? That type of thing. So that's what they mean by qualitative. I like, or we've always done it this way, and it's proven that this is going to work. So yeah, you really don't really have any data, if you like, any numerical data to prove what you're talking about. So financial decision making is normally quantitative. So yeah, obviously you've got other numbers. You've got to prove why you're doing it. So it's quantitative in nature, but may include other aspects involved which are more difficult to quantify, which are qualitative characteristics. So it's the quality of things. So the decisions, for example, not to replace a particular asset may be an unpopular choice with the workforce, resulting in employee dissatisfaction and ultimately employee losses. So, okay, forget everything else about the actual asset. It's just that, in terms of purchase price or productivity or et cetera, but the decision is that this piece of machinery is not working very well, and basically morale is down because of we're getting unscheduled shutdowns and just basically things just grinding to a halt. Obviously, the workforce, people have been out 3 times in the last month trying to fix this thing, and they keep saying to you, listen, this thing is archaic. It's just going to blow up all the time. So therefore, then the qualitative characteristics is that you have an unhappy workforce, you have low morale. And then what happens is people, look, I'm going. I'm not going to put up with this. I'm going to get a job somewhere else. So it certainly has a quantitative measure to it, because obviously you've got to go and replace that person. But equally, it's about these qualitative consequence, I suppose, in that way. So that qualitative characteristics are difficult to express impacts of dissatisfaction in financial terms. Well, yes, it is, and some it is and some it isn't. In terms of people grumbling and low morale, well, yeah, okay, their productivity might drop, but it's hard to argue that's a 10% drop in production or something like that. That's what they mean. But equally, it sort of does have financial impact, that qualitative thing. If people do pack up and go because now you've got to go and replace them, and they're not there to do what you want them to do. So the consequence is that it's difficult to factor into a financial model, obviously, dissatisfaction, etc., etc. But it's not that it can't be. It's just got to be. It's hard to put a number on it, I guess, is what I'm saying. So again, still looking at this qualitative versus quantitative decision-making models. In the model, a quantitative analysis is carried out, with qualitative factors being considered at the final stage. Efforts to otherwise quantify, expressed in financial terms, qualitative factors can result in complex or inaccurate models. So really what it's saying is that here's your number crunching, yibbity, but oh, hang on, and then what will happen if we don't do this? What happens if we do this? So that's where the quality bit comes in. So they're incorporating it, but it's in some ways it's a bit of an afterthought too, though, isn't it? All right, but okay, it's legitimate. So it's one way to do things. Decision-making models for asset replacement. So it's difficult to justify equipment replacement because of high maintenance costs, unless the maintenance cost or the downtime is extremely high. Okay, if you can't kind of justify that, it's hard to turn around and say, oh, we've got to replace this thing. Operational research analysis, this is a mathematical model process, it showed an optimum repair or replacement frequency which results in lowest average maintenance cost for that item. So in other words, you can use mathematical models, and this is just one example. So if your modeling shows this to be true, then the item exhibits a fail pattern strongly indicative of wear, and costs, direct plus indirect, of repair or replacement on the failure is considerably greater than the cost of its fixed time or fixed usage replacement prior to failure. So what this is saying is that you can use a mathematical model to prove your point, or you're going to have to do that to help you prove your point. So these models of hypothetical situations have been developed less for the usefulness than for intellectual pleasure. So what they're saying is that operational research, as an example, what's happened over time is that it's become like more of a mathematical problem. It's been great, but in the real world, it's kind of got lost a bit. So therefore, then it's become more of a modeling of not really the real life situation. So unfortunately, it's undermined that mathematical modeling of operational research in this particular example. So from a real world perspective, the replacement models and replacement decisions basically need to be based on that real world perspective. So the running, repair and acquisition costs, likely income from the sale, the failure pattern, opportunities provided by seasonal or statutory shutdown, reconditioning possibilities, fiscal considerations, tax incentives, import duty, when you go and buy this thing, cost of borrowing, if it's obsolete, alternative investment, more of these are considered. So in other words, you've got to take, in the real world, yeah, you can model it mathematically, but the point of the matter is that these variables, like we're talking about fiscal considerations, seasonal, shutdown, are they being taken into account? Because obviously once they do, there's greater complexity of trying to figure out what's going on here and what the influences are, and obviously what the consequences are. So a few of these particular variables, like, as I say, the cost of borrowing or in their fiscal considerations, then obviously you only run an approximation because you're sort of not fudging. Well, you are fudging, I suppose, in some ways, but it's really just sort of saying, well, have you got a really, is it detailed enough? Is it insightful enough to help you make a realistic decision? So now, the costs of alternative maintenance policies can be directly compared, and cost optimizations achieved using powerful spreadsheet tools which can handle multiple variable situations quite easily. So in other words, the good old Excel spreadsheet, over the years has become quite powerful just as a simple, quick calculation, to be honest, and useful. So that's what it's saying, is that you can do these comparisons, and it can be done very quickly by setting up an Excel spreadsheet. Would be one example of modeling mathematically. All right, so what about some more aspects of financial analysis techniques? Time value of money. What does that really mean? Well, here's a scenario. Consider the difference between investing $100 today for 2 years at a bank interest rate of 10% and receiving $100 in 2 years' time. And this is this bit about that I was saying beforehand about how, $100 today, it was, what was it was 30 years ago, or what is it in 2 years' time, 10 years' time, and trying to compare what the value of it will be. So what you do here is this is how you go about doing it. So if we know that the bank interest is 10% with an investment time of 1 year, and in that first year, you've got your original amount of money, your $100, and then over that year, you're getting your 10% interest on that $100. So basically, at the end of the year, you've got $110. So now, if you take that, and we want to find out what the bank interest, again, is 10% still, and what we're doing is investment time in 2 years, because we want to figure out what it is in 2 years. So in the first year, we were able to take $100 at 10%, and we got $110. So in the second year now, we've got $110 to begin with, and we go through the calculation again, and at the end of the second year, we end up with $121. Seems magical, but not really. So therefore, what that's saying is that the value of your $100 in your hand now is worth 21% more, more than the value of $100 in your hand in 2 years' time. This is irrespective of the effect of inflation or any similar issue. It's just really, in other words, this is not dealing with, it's just dealing as a complete number, just a quick calculation. It doesn't include, calculating inflation, et cetera, et cetera. You'd have to incorporate that, but just as a quick, back of envelope type calculation. So, say it again. The value of your $100 in your hand now is going to be worth 21% more than the value of that $100 in your hand in 2 years' time. Okay. So we can also reverse the process, because that comes in handy when we want to work backwards to try and figure out how much we're going to have, in today's money. Now we can say again, $100 available in 2 years. Time should be discounted by the original amount divided by the final amount. So that was $100 we had originally, and from that 2 years investment, we had $121. So we get this little multiplying factor, 0.826, and we have what we talk about as the net present value of $100 in 2 years. That equals this little ratio, this little percentage, or this little decimal, 0.826 multiplied by that $100 we got today. So that equals, in this case, $8.26. So that will be seen that the higher the rate of interest, the higher the discount rate will be. All right. So this is sometimes called the time value of money. This concept lies at the heart of most methods used to evaluate capital expenditure, which includes all large replacement projects. The calculations may be changed around depending on where the variables are known and which ones have to be calculated. So obviously the rate of interest changes from bank to bank and from year to year and from financial periods to financial periods. But basically, we can do that simple little calculation using that formula. All right. So another financial analysis technique is the payback period, and this is calculated by counting the number of years it will take to recover the cash invested in the project. So let's assume that a company invests $400,000 in more efficient equipment. The cost savings from the new equipment is expected to be about $100,000 per year for 10 years. So crude method, because it doesn't take into account the taxation, depreciation, or any long-term effects, changing market share or higher future values, we need to be aware of projects also which are limited life. In other words, you know yourself too, you're doing something and it really doesn't have a long-term life. It's just something you have to do to enable you to do the next stage or to get you through this particular stage. So be aware of these projects with limited life, 2 or 3 years, and then they run out of some vital ingredient. They may show a good initial payback, but will falter before the project has really paid off. Possible advantage of considering this payback period is that it gives a priority to a good project with very short payback, say less than a year, so that's a good guide, and justify diversion of your resources to accelerate that approval process, or conversely kill off a poor project without spending a lot of resources on it. So that's what we're saying. If you sort of do a quick calculation and say, this is good, this is going to work really well because within less than a year we'll get good payback on this, so therefore then we should go this way. Or so you go through and accelerate and get going. Or you can you can turn around and say, oh, hang on a minute, no, this is going to be more costly in terms of our initial investment, so therefore then no, we won't go that way. We're going to have to figure out some other process. That's really what that's saying. Still looking at financial analysis techniques, discounted cash flow, return or investment. So a method of valuing a project, company or asset using the concepts of the time value of money. We said before, the time value of money is the amount available at the present time is worth more than the identical sum in the future due to its potential earning capacity. We saw before when we were able to invest it at 10% for argument's sake. There could be other percentages. This is a core principle of finance such that provided money can earn interest, any amount of money is worth more the sooner it's received. Okay, so all future cash flows, income or expenditure that are expected to occur in the future are estimated and discounted by using the cost of capital to express the cost in current value terms. As I say, I'm not trying to turn you into an accountant, but again, sit down with your accountant, have a chat about it, or your financial people, and get a bit of a, say to them, oh, I've got this D10 over here. Can we talk about some of these concepts? The organisation's cost of capital is the company's cost of funding. This will depend upon the organisation's capital structure. That is the cost of debt as well as the cost of equity. So you've got a large company, they might have a lot of debt. So therefore, then yes, they might be a multi-million-dollar company, but the reality is that there's they got a lot of debt, and they might be working their way through that over a 5-year plan, for argument's sake. Their profitability is going to go up because their debt's going to go down. So the cost of debt is the organisation's cost of raising funds through debt financing, interest-based loans, basically. The cost of equity is the organisation's cost of raising funds through equity offerings, like company shares and stuff like that. So this is the basis for comparison of options with cash flow occurring at different times. Cash flow is discounted by the real uninflated interest rate, defined as the increase in real purchasing power expressed as a percentage per period. The value will change and best determined through the discussion with the company's finance department. Also referred as the present worth or the net present value. So as I say, some of this terminology, depending on your organisation or your financial person. So again, I strongly suggest go and have a talk to the people that are in your financial department or the people that are within your maintenance unit that deal with the financial matters, and test some of these ideas out. So the financial analysis for the present value formula, what this present value formula does, it provides a quantifiable, so in other words, gives you a number, quantifiable comparison between an amount today and amount at some future time in terms of its present day value. So as I say, it's just trying to bring back to you just to say, okay, in terms of today's money, how does that compare? That's really what it's all about. So you have this little formula. As you can see, the discounted value A of an amount money, the cash flow and present, divided by 1 plus I, which is the real interest rate, to the nth power, which is the number of years or whatever the time period might be that it's under consideration. So let's have a look. Determine the present value of $100 in 10 years' time, assuming a real interest rate of 7%. So the discounted value of the amount of money, that is the cash flow in the present, in other words, $100. How many years are we doing? 10 years, that's right. And what's our real interest rate? So 7%. Now again, that might be 3% this year, 5% next year. So that could be like an average value. It could be, some sort of, it's not going to be necessarily 7% completely. You know what I mean? It might be the average value or something like that. Or it could be, you could have invested for 7% and that's what it is. So the present value of any amount of money that's received at that future time. So in other words, I've got $100. This means that when I do my calculation for those requirements of $100, 10 years, and at 7%, this is the amount of money which would need to be invested now at the interest of 7% to have a value of $100 in 10 years' time. Okay. We can talk about a discount factor. It's just the 1 over the 1 plus IN part of that particular equation. And you can look up tables and the whole, so that gives you comparative things to help you figure out whether or not, that's a viable option. So for example, you might look up for this particular one that we're talking about here, the discount factor is 0.5083 now. Again, when you do another calculation for a different percentage in a different time period, you'd be able to compare the discount factors, and of course that would help you make your decision. What about this example? Discount cash flow for replacement analysis. This is that example in the study guide, example 3.2. So you've got a fleet of 10 trucks has been in service for 10 years. Significant maintenance is due on the trucks and is expected to increase the current operating and maintenance cost by $30,000 per year per truck for a period of 3 years. Management believe that there is a case to replace this fleet of trucks. The annual operating and maintenance cost for the fleet of trucks is $50,000 per truck per year. It's expected that the maintenance program will enable the truck fleet to survive for 10 years, at which time they'll have a zero salvage value. In other words, they're worth nothing. 2 replacement candidates can be considered. So, okay, you sit down and you sort of think, okay, option 1, what can I do? So option A, operations have advised that 7 trucks of the type option A will be required to match current production of the existing trucks. The new trucks cost $180,000 each and are expected to have an annual operating and maintenance cost equivalent to that of the existing truck for a 10-year period. The suppliers offered a trade-in, again, on the old trucks at a rate of $10,000 each. It's estimated that the salvage value of these trucks will be $15,000 in 10 years' time. That's one option. Another option is the production planning have advised that 6 trucks of the type option B, of this option, will be required to match current production of the existing trucks. So the new trucks cost $250,000 each and are expected to have an annual operating and maintenance cost equivalent to that of the existing 10 trucks for a 10-year period. So the suppliers offered a trade-in, the old trucks at a rate of $13,500 each. It's estimated that the salvage value of these particular trucks will be $20,000 in 10 years. So the real interest is really 7%. So again, look at these options. The following cash flows are associated with each option. Note that the payments or outgoing cash flows are negative as indicated by numbers within parentheses, in brackets, in other words, while income is positive. So if we look at retain the current trucks, then in year 0, it costs us nothing. From years 1 to 3, it's going to cost us $800,000 operating and maintenance costs. From 4 to 10 years, $500,000 operating and maintenance costs. So if we go for option A, in year 0, our capital costs would be $1,260,000, the $100,000 value of the old trucks. Year 1 to 10, $350,000 operating and maintenance costs, and then in year 10, we've got a salvage of $105,000. And the option B, similarly, if we do our calculations, we'd have $1.5 million capital purchase price, $135,000 value of the old trucks, and then as you see, 1 to 10 years, that's $300,000 operating and maintenance costs, and then in year 10, if we want salvage of them, $120,000. So crunch out your numbers, and then what you find is you start looking at your calculations for each year, your factors, and then here's your option A and your option B, and of course it's going to turn out in this case to be option B. So let's look at your numbers there. So that's $3,411,000. This is $3,564,876. So 100,000. 50,000 roughly. So the result shows that there is a distinct case for replacing these trucks. Option 2 has the lowest total discounted cash flow, and it's a recommended option in this case. Note that the results tell us that option 2 is the lowest cost option as the lowest negative total cash flow. Calculation using the example of being greatly simplified, it's possible to extend this analysis to include the effects of depreciation. So in other words, these things have to be taken into account. Depreciation has to be taken into account, tax to deal with after cash flows, but if you put those things in, then obviously you get a truer model and you get a better idea. This is like a quick rough calculation to sort of see what's going on. So it's about $150,000 difference there. This type of analysis is best dealt with in conjunction with the company's financial department, as I was saying beforehand. Keep talking to that financial department or the people in your unit that are financial people, and keep talking to them about various tax arrangements, payoff options, and that type of thing. So, what have we done? We've been considering aspects of financial analysis and maintenance management. In particular, the focus you should take away is that, that life cycle costing analysis and some of the decision-making models that are qualitative and quantitative. And as I say, it becomes complex very, very quickly because it's about financial things that, as I say, understanding those terminologies and then seeing how that gets put into place. So some little calculations there. But my recommendation, as I've said all the way through, is that go and talk to your financial people, whether it's within your unit or within your organization. And again, just keep in mind, you don't have to be an accountant to figure this stuff out. That's why you have those people in your organization. All right, take care. All the best.